All right, this is the Chapter 1 review problems. You can find this on page 31 or thereabouts, page 31 of the e-text. Of course, you got to go online to do that. All right, so these are the problems. Keep in mind, not the multiple. There's some multiple choice stuff there. I'm not going to go over that. All right, so these are mathematical problems. All right, so the first one, I'm just going to read it to you. It says, how far does light travel in 1 second? And then if light were leaving Houston, what location on Earth or beyond would it reach in 1 second? All right, so we're going to look at this this problem. So the basic idea is this, right? The speed of light is given the symbol c, and so c is 3 times 10 to the 8th meters per second. So that's a constant speed, right? Well, not all of them, but lots of experiments that we've done over many years has shown that this is the speed at which all electromagnetic radiation, including visible light, travels. All right, so this is actually the same speed that radio waves travel, that same speeds that microwaves travel, and so forth. All right, so I'm going to put this in other units as well. So instead of meters per second, we're going to do it in kilometers per second. So it's 3 times 10 to the 5th. That's supposed to be a 5 to the 5th. Sorry, that doesn't really look like a 5, does it? Sorry, let's erase that real quick. All right. So 10 to the 5th. Hopefully that looks better. And that's kilometers per second. All right. So we're going to actually use this second one. So sometimes we'll use 3 times 10 to the 8th. Sometimes we'll use 3 times 10 to the 5th kilometers per second. So in this particular case, c is, of course, as I already said, a constant of the universe. But any speed, as long as there's no acceleration, speed, that's what this is, c, is equal to the distance divided by the time. All right, and so really what we're looking for in this equation, so this is our equation right here, is the distance that light travels in 1 second. All right, and so if we rearrange this equation with a little algebra, and this is just algebra 1, then it says that d is equal to the time t times the speed of light. All right, so this is the equation that we're going to use to solve our problem. All right, let me pause this. All right, so I paused it just to so we could erase that. All right, so anyhow, so we have this equation: distance is equal to time times the velocity, which in this case, of course, we're talking about the speed of light. All right, so let's go over the units. Now, if we choose the speed of light as kilometers per second, then the time t has to be in seconds, and d, since c is in kilometers per second, d will be in kilometers. All right, so here let's write this out. Okay, so we've got 1 second, right? That's what they told us. 1 second is the amount of time that goes on, so that makes the multiplication quite easy. Times 3 times 10 to the 5th kilometers per second. All right, so notice when you multiply these, the units of seconds cancel, right? So this seconds and this seconds cancels, and that gives us a distance of 3 times 10 to the 5th kilometers. So in 1 second, light travels 3 times 10 to the 5th kilometers. And this is actually really close to the distance to the moon, just to let you know. It's not exactly, the moon is like 384,000, so it's close, right? So the just to let you know, the distance to the moon, a lot of times in astronomy and physics and in all the sciences, we'll put these subscripts, right? Like d sub moon. So that's just to indicate that the distance to the moon is 384,000 roughly kilometers. All right. So when we compare 384,000 to 3 times 10 to the 3 times 10 to the 5th, it's 300,000 kilometers. So it's almost all the way to the moon. All right. So that was just to remind us, that was problem 1. All right. So let's see. The next one is do I want to do all of it? Yeah, I might as well. Okay. So the next one is just make sure you know how to do go back and forth between scientific notation and just the more familiar notation like this, right? So for example, let me just say the distance to the moon. Okay, so this is not problem 2, but this is very much related. The distance to the moon is 384,000 kilometers. So if I were to change that to scientific notation, see that the decimal place is right here after this, after the the third 0. So basically, what that means is if I move the decimal place 1, 2, 3, 4, 5, right, 5 places to the left. Right, so I move that decimal place that way. That means that I can rewrite this as 3.84 times 10 to the 5th, right? Because I moved the decimal place over five places, right? Kilometers. And so it actually now you can see that 3 times 10 to the 5th and 3.84 times 10 to the 5th are pretty close, right? They're not exactly the same, of course. All right, so number 2, let's look at number 2. So they just give us a bunch of yeah, what happened? Okay, what happened? All right. All right, so let's see. So number 2 it starts out with 1,000. It says use the notation to write stuff in use the familiar notation to write stuff in scientific notation. All right, so this is number 2 that I'm talking about, and so they start off with 1,000. I don't know if I'm going to do all of these. All right, so this is just a number, and so to write this in scientific notation, right, the decimal is right here. It's implied. It's not shown, but it's implied. It's right there. So if I move the decimal place 1, 2, 3 places to the left, then that becomes it's the exact same thing. 1 times 10. Since I moved it 3 places, it's 1 times 10 to the 3rd. All right, what's the next one? The next one is, here, it's going to be 0.000, I got to count the zeros here. 1, 2, 3, 4, 5, and then a 1. 1, 2, 3, 4, 5, and then a 1. All right, so it says to rewrite this in scientific notation, okay? So this is, to write it, basically I've got to move the decimal place behind the 1, all right? So how many places am I going to move it? 1, 2, 3, 4, 5, 6, right? So I can rewrite this as 1 times 10. So it's basically, how much do I have to move the decimal place to get back to this original number? And so it's going to be 1 times 10 to the minus 6. The minus sign, of course, means to move the decimal place of this number here to the left. And then for this one, the decimal place is right here behind the 1, so it says move the decimal place 3 places to the right. All right, -6, you move it 6 places to the left. All right, so that's that one. The next one is 1001, and so it says, right, sorry, there's supposed to be a 0 there. So write that in scientific notation. That would be 1.001 times 10 to the third, right? Why is it to the third? Because, see, I have to, to get back to the original number, I got to move the decimal place 3 places to the right. All right, the next one, actually, let me pause this, because, all right, I've written the next 3 problems. All right, so this one has a 1, and notice, we group things in 3s. A lot of times they separate them by commas, so, we've got how many zeros basically after the 1. So we got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we're up, we're up to 12 and then 15. All right, so this is actually, this one's pretty easy. It's just 1 times 10 to the 15th. That's supposed to be a 5. So 1 times 10 to the 15th. See, I mean, it's when you get these really large numbers like this, and especially in astronomy, really in any of the physical science, any of the sciences, sometimes you deal with really large numbers, sometimes you deal with really small numbers. So that's all right. So always just try to do this as I'm doing it. I'm just trying this or showing you this to help you. Many of you, I'm sure, have already seen this stuff, but it does help to review it, because this is the kind of thing that we're going to see when we do the homework for chapter 1, for example. There'll be some problems. All right, not many, but there'll be a few. All right, so for this one, the next one, so it's 123,000. So if I want to put the decimal place behind the 1, so it's going to be 1.23. 1.23, and then where was the decimal place? So it was right here, so I moved it 1, 2, 3, 4, 5, right? So it's going to be 1.23 times 10 to the 5th. All right, so that's putting it in scientific notation. Okay, so the next one is 0.00456. All right, so that's going to be rewritten as 4.56, and then, where does the decimal place have to end up? It's got to be behind the 4. So how many places do I have to move it? 1, 2, 3, 4. Okay, and then remember to go back to where it originally was, I've got to move. That means I've got to move it 4 places to the left. So that's to the -4th. Oops, sorry, so times 10 to the -4th, sorry. You got to write the times 10, that's kind of important. All right, for part B of number 2, they want us to change these values in scientific notation and change them to, quote, normal numbers. All right, so this is fairly straightforward. So 3.16 times 10 to the 7th, so I got to move the decimal place 7 places. It's positive, so to the right, so it would be 3. So this is 1, 2, let's see, 0. So 1, 2, 3, 4, 5, 6, 7. All right, so let's see, we're gonna make sure that looks right. So it should have 1, 2, 3, 4, 5 zeros, yes, 1, 2, 3, 5, good. All right, so the next one is 2.998 times 10 to the 5th, so that would be 2, and then, the 998, I've moved the decimal 3 places, and then 2 more, 0, 0. All right, so that now I've moved the decimal place 5 places to the right. All right, so notice this one is to the -11th, 6.67 times 10 to the -11th. So let's do that. So we're going to do 0. All right, so we've had to move the decimal place from here 11 places, okay? So